thank you for being here today, and obviously we're talking about Aurelia, and who am I? Who's this guy up here talking to you about this strange thing? I've been working, my name is Rob Eisenberg. I've been working in open source for about 10 years now, primarily building frameworks for front-end development. If you recognize my name, it may be from Calibre Micro, which was a XAML-based framework that I wrote that's used across a whole bunch of different Windows platforms. Or maybe it's from Durandal, which is a JavaScript single-page app framework. You might also know me as the guy who left Google's Angular 2.0 team to go build his own thing. So I worked with them for about 10 months. We had a build-up of many differing opinions, and I left back in November to work on what I'm going to be showing you today. So, and what are we talking about? Aurelia, which is a new JavaScript framework for building rich apps in the browser, on tablets, on phones, desktop, everywhere. We're going to talk about a few different things. We're going to build an app in the middle, but we're going to start by talking about a little bit more detail about what Aurelia is and why we're building it. Then, like I said, we'll build a simple application with it. And then we'll talk about the status of the project and the next things that we're working on. So first, what and why? Well, what is Aurelia? It's just JavaScript. Although it may be a little bit different than the JavaScript that you've seen before because it's actually written with ECMAScript 6, or you may know that as ES 2015, which is the latest specification for JavaScript. And if you haven't looked at that before, it's going to look a little bit different to you because it's almost like a complete new language in the browser because of just the number of new features like modules and classes and arrow functions and promises and all sorts of really interesting things. But ECMAScript 6 and ECMAScript 7 really transformed the browser into a much more robust programming platform from a language perspective. And so Aurelia is one of the first frameworks to be written with modern JavaScript. Now, it actually breaks down into a collection of libraries. So it's not one gigantic monolithic JavaScript file, but it's actually split across 24 or so different libraries. And some of these libraries you can even use on the server side. Some of them you could use in a standard web app or website. So many of these libraries are standalone and can be pulled out and used on their own for different purposes. An example of this is we have dependency injection support in Aurelia. But you could take that library and use it all on its own in a Node.js server-side application if you wanted to. So Aurelia is highly modularized, and many of the parts are reusable. And many of the parts are swappable, so you can customize the framework as well. What is it for? Well, like I said, it's a bunch of small modules, so you can actually use it for a lot of different things. But if you use them all together, the primary purpose is building JavaScript clients or single-page applications. This is the intent of this is to build rich, native-like experiences, but that are built with web technologies, HTML, JavaScript, and CSS. So these apps run in the browser, but they can also run inside of a host like PhoneGap and run on the phone or the tablet. Or you can use something like Node WebKit to run these on the desktop. So the idea is we want to write with JavaScript, HTML, and CSS and be able to deploy it to every platform. Talk a little bit about the philosophy of Aurelia. First of all, it's open source. It's completely open source. It's MIT licensed, which is a very permissive license. So when you use Aurelia, you're not going to have any need to worry about us doing evil things or making evil claims on your app, all right? So it's completely open source. You can take it and use it pretty much any way you want. We focus on clean code, and as we build an app, you're going to see that most of the code that we're going to be writing in our application is very clean, very simple, what I would call vanilla JavaScript. In other words, you're not going to actually see the framework itself very much. The framework is designed to allow you to focus on your own code and without being distracted by lots of library calls and and strange little bits that kind of invade or infect your application code. We do this in a variety of ways, but one of the things we use is simple conventions. We try not to go overboard on conventions, but we have a few lightweight conventions that allow you to follow very simple patterns, and therefore the framework can do a lot of work for you in helping you build an app quickly. We also focus on testability. Our framework itself is modularized and testable and tested, and we want you to be able to write code for your apps in the same fashion. In other words, you should write your apps the same way we've written the framework, by creating simple, small, focused modules that are decoupled from one another and that are testable. And in fact, our starter kits get you set up with both unit testing and end-to-end testing. So when you get started with Aurelia, you don't have to do any extra work to basically start writing tests for your app. The cool thing about Aurelia is we just announced the community preview. It's sort of like an alpha back about 6 or 7 weeks ago, and already we're seeing a huge uptake. There's a very large community and very active community growing around it already. So you can get involved. There's lots of people building all kinds of stuff on pretty much every platform and every vertical. So you can join that community, ask questions, send pull requests, contribute by writing blogs or just building sample apps and enjoying kind of playing around with it. But there's a lot of people doing that right now. And it actually, I had hoped, of course, that this would happen, but it surprised me how quickly and how mature the community is already. Another important point about Aurelia is that while it's open source, it's actually commercially backed by a new company called Durandal Inc. And I'll talk a little bit more about, and we also have several partners. I'll talk a little bit about why this is later. But if you're building very complex JavaScript apps, there's not a lot of places you can go right now to kind of get a baseline open source platform and also be able to get some sort of commercial support for your business or the enterprise. And this is proved to be difficult over the years with other open source frameworks for companies that really want to adopt and gain from the economic benefit of writing once and running everywhere, but they're afraid because there's no support model around it. So that's one of the things that we're doing with this company, and that's why that's there. Okay, but why are we building this anyways? I mean, there's like a new JavaScript framework every week. There's other stuff out there. So why? Why even bother with this? Well, first of all, like I mentioned, ECMAScript 6 is being ratified in just a couple months. And this is the largest upgrade to the language in the browser in its history. Fundamentally transforms the language. And when we have these new language constructs, this new syntax, this new way of thinking about JavaScript programming, we can build different ways, come up with different ways to build apps that are much, much nicer. And so there aren't really any frameworks that do that yet. So Aurelia is one of these frameworks that's very forward-looking at the next generation of browsers. Of course, it lets you do it with today's browsers. But that's one thing. We also have a modern DOM. Many of the libraries and frameworks that are written are based sort of on the document object model of years ago and the performance of years ago and the browser quirks of years ago. But that's actually evolved quite a bit. The DOM is much faster today than most people think it is. It also has a lot more friendly APIs available. There's very little reason, for example, to use something like jQuery if you're targeting modern browsers. In fact, it's much faster, in order of sometimes 10, 12, 20 times faster to use the DOM API instead of using jQuery. And there's very little need for that anymore. So we want a framework that actually goes straight against the metal there and leverages the modern DOM performance and APIs. And then there's something called web components that's on the horizon. And this is sort of in a specification stage, and it has a number of issues, but one way or another, we're going to get native custom elements and native modularity and extensibility of HTML. And we need frameworks that are prepared to deal with this. Many of the frameworks today are not compatible or don't work very well with the idea of web components. So we need to have a design that is forward-friendly and prepared to work seamlessly with web components. It's also nice if we have a framework that doesn't have any external dependencies. So we're not beholden to this library or that library or some other company and their release cycle and so on and so forth. So Aurelia has no external dependencies except polyfills. The polyfills patch up areas of the DOM across browsers for future specs that haven't been implemented yet. So the idea behind Aurelia is that over time our framework is actually going to get smaller because we're going to start dropping away these polyfills because they're going to be natively implemented in the browser over time. So at that point there'll be absolutely no external dependencies whatsoever on the library. And so you can kind of take the library and use it and not have to worry about patching together a whole bunch of other things to make an app. We want a simple, powerful programming model. I don't know if you've looked at a lot of the different libraries and frameworks that are out there, but there's often a very steep learning curve. It's difficult to understand how to get started, and there's lots of API calls to learn. So we really want a very simple model, not simplistic, but simple. We want to be able to build very complex applications, but do it with a simple mental model, and not have to spend a lot of time learning a whole bunch of different things. We want something that has modern and future compatible two-way data binding. So there's new specs coming in ECMAScript 7 for native observability of objects in the browser, and we want to have a data binding system that is prepared to leverage those capabilities when they arrive. And so we have two-way data binding in Aurelia. It actually will use this new specification if the browser implements it, and if not, it implements a fallback pattern that behaves the same way. And we have what we call an adaptive data binding mechanism, where we can observe anything in the browser, and we pick the correct strategy, the most efficient strategy based on the capabilities of the browser and the thing we're observing. And so we have a very powerful kind of next generation data binding engine based off of future technologies that we've polyfilled for today. Like I said before, we wanted to have a library that we could reliably provide commercial support for, because this is a big issue. I'm on a number of mailing lists and talk to a number of people, and they say, we love library X or library Y, but the big problem is we can't get any support on it. If something goes wrong, we're pretty much dead in the water. It doesn't matter if it comes from mega company X, there's no offering in that space. So we wanted to have a library that we could confidently and reliably provide that service to the people that are interested in it, the companies that are interested in it. We also want a pathway forward for Durandal users. Does anyone use Durandal out there? So this is an existing JavaScript framework that is actually quite well used by big and small companies all over the world, and we wanted to have a pathway forward for the community into the next generation. So Aurelia basically uses a number of the same patterns and ways of building apps, but kind of brings them into the next generation. We also wanted to have a pathway forward for Angular 1 users. I don't know if you are familiar with Angular, if you've been tracking what's happening there, but there are some very, very serious changes between Angular 1 and Angular 2. And there are some very significant features that are being removed that how to say this politically correct. I've noticed a number of members of the community, significant number of the community, that are not very happy about this. And so we want to provide a pathway for them so that they can have a path to migrate their Angular 1 apps into a next generation framework without having to completely re-architect and redesign the way they're even thinking about building apps, which will be required in a number of cases with Angular 2. So this is also about migration into the next generation for people building on existing platforms today. All right, so let's build an app. That's enough. That's far too much talking. Anyways, you all are developers, so let us build something. Before we actually build it, I want to show you what we're going to build. Actually, before we do setup, I want to show you the app. It's a real simple little app I have running in Firefox here. It's a little contact manager app. None of these people are alive, I don't think. They're people I wish that I knew. So we have a list of contacts on the left-hand side. It says, please select a contact. As I select one, it loads it from the web service, presumably, and it loads the details in, and I can navigate between the different contacts, and it will load and display them. And you probably can't see this as well, but the URL is being updated up here to match each contact. So we have deep linking. If I just refresh the browser right there, it will come right back to the selection that we have. Of course, I can change the name here and save it, and everything updates, so on and so forth. So this is a pretty simple, straightforward app. We're not going to do all of it during this session, but we're going to build several key components, and hopefully you'll get the feel of what building an Aurelia app is like. Hopefully it will make sense to you. I think it will. So when you want to get started with Aurelia, you need to basically set up your development environment first. I realize that's probably a little bit small, but the first thing it says is download the skeleton and unzip it. So if you go to github.com/Aurelia, there's a repository called skeleton-navigation, and this sets up a basic navigation style application for you. So you can go there, you can download the zip of the latest release, and you can unzip it, and this will give you all the source that you need for a simple little app, and everything is basically configured and set up for you. So you just need to basically install the build tools. So how do we do that? Well, first you need to install Node.js. If you're not familiar with Node.js, it's pretty much the de facto standard for JavaScript development. It's not just for server-side JavaScript development, but in fact, pretty much all of the build tooling around rich client JavaScript is on top of Node.js. So if you're going to get into building rich JavaScript apps, you're going to be running tooling on top of Node.js. So you're going to want to download that and install that. And of course, it runs cross-platform. So wherever you're coming from, Mac, Windows, Linux, you're good to go. Once you install Node.js, inside of that skeleton folder that you've unzipped, you want to execute this command on the command line, npm install. npm is Node's package manager. So what this is going to do is going to bring down all the dependencies of this starter kit. So we're going to set you up, like I said, we're going to set you up with unit testing. We're going to set you up with end-to-end testing. We're going to set you up with a transpiler named Babel that is going to allow you to write ECMAScript 6 code today, but it's going to convert it to ES5 that runs in today's browsers. We're going to set you up with linting. We're going to set you up with change tracking for releases. A whole bunch of different stuff that you're going to need when you're building a real project is already in there. Once you npm install, we'll bring down all those build dependencies for you. Again, not required for Aurelia, but our starter kit tries to get you going with something that's a very professional quality setup. So this is how we're setting up the tools for that. You then want to install something called JSPM, which is a JavaScript package manager. And this is a package manager geared for client-side development, right? And it has a built-in knowledge of ECMAScript modules and module systems and loaders. So it makes the experience of working in a client-side JavaScript app basically the same as building native apps in terms of installing new packages and then referencing the code and using it in your own app. Then you're also going to want to install Gulp. This is the actual build automation tool, if you will. We have a bunch of Gulp tasks set up in the starter kit for doing all the things I talked about, testing, linting, all sorts of things. I'm not doing it all because it's pretty boring to show you this and just stare at a command line while we wait. And then the final thing, once you've got JSPM installed on this step here, you then want to run a JSPM install, and that's going to bring down and actually download all the client-side libraries. So that's going to bring down Aurelia. That's going to bring down, in this case, it's going to bring down Bootstrap and Font Awesome, just so you have some nice styling and layout stuff to begin with. And that's how you'll actually install any client-side dependency that you need. And then you start developing. On the command line, you type gulp watch. We'll set up a temporary server to serve up your static assets, and then you start developing in the browser. As you change files, we'll automatically refresh the browser. Our setup also sets you up with browser sync, so if you want to test across multiple browsers and devices simultaneously, it will synchronize across all the browsers automatically for you. All that's set up in there. But enough of that. The code. Let's write some code. And I am going to jump over here and kill that off. That was our final app that I was showing you a moment ago, and we're going to begin starting work on this thing from scratch. What I've got here is Atom Editor. I wish they could dim the lights in here, but hopefully you'll be able to bear with me and read this. There are a number of tools we'll talk about for building ECMAScript 6 apps. WebStorm is great, Atom is great, Sublime is great, and there's support coming to other tooling as well. So I'm using Atom here, and this is basically just the skeleton that I just told you about with everything all pre-installed and configured, so we don't have to deal with that. The main place we're going to be working is in the source folder. We're going to put JavaScript and HTML in there, and we're going to end up with the app that I just showed you. So the first place that we want to start when building an app is in our index.html file. The same place you would start typically when building any standard web application. So I want to show you how that's set up. So this is the index.html file, and this is basically going to look the same for every Aurelia app. In the head, there's a couple of links. The first two are Bootstrap and Font Awesome. Those are not required by Aurelia. They're just here in this sample, so I can make it look halfway decent. Also, the styles link up there is styles that I've pre-written for this sample application. So you don't need any of that, but it's just in there. The part where it becomes interesting is in the body. And if you look on line 9, the first script tag is referencing that JSPM library, but it's referencing system.js. So this is a module loader built on the ECMAScript 6 standard for loading modules. So this is going to handle importing all our code, resolving all our dependencies, and making the ES6 module system work very nicely. On line 10 is config.js. This is just some generated code that is generated by JSPM to tell it where to find all the modules. We don't even need to look at that or worry about that. That's handled by the tool, but we need to include it so the module system can resolve modules. And then on line 12, this is where things get kicked off. The system API is actually part of the browser in ES6. That's how you reference the ES6 loader. And this is how you import code in ECMAScript 6. So we're basically telling it to import Aurelia's Bootstrapper module. And when that module loads, it's going to inspect the HTML page, and it's going to look for anything that has an Aurelia-app attribute. And you can see that the body has that attribute on line 8. And it's going to assume that you actually want to render an application inside of that node. And it's going to follow some very simple conventions in order to figure out how to load your app. It's going to actually look for a file called app.js, and it's going to look for a view called app.html. So very intuitive, very simple, makes a lot of sense. So we're going to build those files in a minute, but before we do that, I want to talk about the simple convention and pattern for building Aurelia apps. Everything you build in Aurelia is going to be divided into two parts, essentially. A view model written in JavaScript and a view written in HTML. The view model is going to be a JavaScript class that has the behavior for your custom element or for your screen that you're working on or for your component widget, however you want to, whatever it is you're building. It's all built the same way. So you're going to have a JavaScript class that has your behavior and your state in it, and then you're going to have an HTML file that's going to have an HTML template in it with binding expressions that declare how the class and the template are connected to one another. And then the framework is going to keep them synchronized real time, automatically. So once we have this index.html file, we can go ahead and actually come over here and run our app. We haven't written any actual code yet, but I'm going to go ahead and start up the server. And we can jump over here, and it's refreshing, and there's nothing in there. So that's not really unexpected. And if we look down here, there's an error, and it's telling us that it can't find the app. Can't find app.js. So we're going to come over here, and we're going to actually write that app.js. And the app.js is going to be what I call our main view model, or you can think of it like a main window or a shell or the Chrome of your application. It's going to have the title bar, and it's going to have the zones where we're putting the content and the list and the other widgets. Okay? So we're going to begin by creating app.js and app.html. So I'm just going to new file app.js, and I'm going to new file app.html. I'm going to create the HTML file first. I'm just going to go ahead and put a bunch of code in here real quick so you can see a little bit of what this looks like. I'm going to save it. So like I said, every view that you create is going to be an HTML template. This is part of new browser standards, this template element. Let's just create DOM that isn't active yet. We're going to manipulate it, and then later it's actually going to render. And then inside of there, we just pretty much have standard HTML almost all the way. We've got a bunch of bootstrap classes to make things look nice. It says contacts, yada, yada, yada. The interesting thing is on line 12, this is an HTML element you've probably never seen before called router view. And Aurelia provides the ability to create custom HTML elements, and this is one of the ones that it provides out of the box. And what this does is it displays the current screen for whatever the router based on the URL says that we should be looking at. So as you navigate from link to link to link, this view is actually going to render in this position the current screen based off of the router. So, what's the router? Where is that? Let's go ahead and set one up. That's going to be in our app.js. And this is going to introduce you to a bunch of different concepts in Aurelia. Like I said from the beginning, all our code is written with ECMAScript 6. So if you haven't looked at that before, this may look a little awkward for you, but this is JavaScript. This is JavaScript. So lines 1 and 2, we're importing modules. Remember, ES6 now has a module system, a real module system. So we're importing modules, and we're giving it relative paths, or in this case, Aurelia router, we're bringing in from the framework, and we're saying what we want to import from those modules. So I'm importing the router, because that's coming from the Aurelia router, directly from the framework, and then I'm importing this thing called Web API, that's coming from Web-API. That's basically my fake backend for this project. So we're not going to get into backend programming. I created a simple module that emulates a real web service in the background, including, faking out like 300 milliseconds of network latency and all this kind of stuff. So we're not going to dig into that, but just know that that's what it is. That's what gives us the context. And then, like I said, our pattern for Aurelia is to create an HTML template and then a class. So we're going to export from our module a class named app. And classes in ES6 have a standard set of features you might expect, like constructors and properties and static members, inheritance, all this sort of stuff. But we're just creating a plain class, and we're setting up the constructor. And in that constructor, we want to get an instance of our router and an instance of that web API. And Aurelia, as a framework, supports dependency injection. So it's the thing that's going to give you those instances. And how do you tell it what dependencies you have? And that's done by line 5, where we have this static inject method. So when you write a static inject method, you return an array, you give it a list of types, and the dependency injection framework will ensure that you receive the instances of these types pushed into your constructor. So this helps you to write very decoupled code. You don't have to put everything in one class. You don't have to strongly couple one object to another by newing it up manually internally. You can just say, I have a dependency on the router. I don't care how I get it. I don't care where it comes from. Just make sure I have a router before you render this screen. So here we're telling the framework to basically give us a router and give us our API so we can work with it. Then we're just storing those in properties, and then we're configuring the router. And this is part of Aurelia's API, just about the only part you're going to see today. What we're doing is we're mapping some routes. If you've used any kind of server-side route framework, this is pretty much the same thing. The route is a pattern. Every time that pattern is matched, we're going to load the module listed by module ID. So when we've got the empty route or the default route, we're going to look for a module called no selection because you haven't selected a contact. And we're going to render that into that router view that we looked at before. Anytime we match the pattern contacts, whack, and some ID, then we're going to render a module called contact detail. Now none of those exist yet, but this code will actually work partially. So let's go ahead and save this. I need to restart the server, I believe, real quick. And then we're going to jump over to our app. And you can see it's actually rendering now. But there's an error down here that says it can't find contact details. You can see there's that header that we rendered out, and then there's this big open space where the rest of the stuff's going to go that we're going to build out. Okay? So, the first thing I want to load up, I want to work on is that no selection screen. How do we build an actual screen that's going to render dynamically in here inside of that router view? Well, we're going to follow the same exact pattern that we just did. We're going to create a module called no selection, and then we're going to create a view called no selection. We're just going to put a class and a simple template in there. In fact, you're going to hear me droning on about this because this is the way we build everything in Aurelia. You want to build a custom element, you build it that way. You want to build a screen, you build it that way. You have a screen that has subcomponents and subscreens all inside of it, you build it the same way. You can organize your code any way you want, but you follow the simple pattern and you can build pretty much anything. So let's create a new file called noselection.js, and let's create a new file called noselection.html. And let us go ahead and, I'm just going to drop some code in here. And I'm going to drop some code in here. Let's start on the JavaScript side actually this time, so you can see a very, very simple screen. Absolutely just about the simplest screen you could write. So again, like I said, we just export a class. It's just a standard ECMAScript 6 class. There's nothing special about this. It has a constructor. In the constructor, it sets up a message called please that says, please select a contact. Very, very simple, clean JavaScript code. In our HTML file, we have a template. Very, very simple, small template. What you can see is on line 3, what we have here is what's called string interpolation. And this syntax actually comes from ECMAScript 6. It comes from JavaScript. And what that's going to do is that's going to take that value, that message property from the class, and it's going to push it into the content of that h2 tag. And it's actually going to keep it synchronized in one direction. So every time it changes in our model, it's going to update it there. All right? We're not going to be doing any changes really in this example, but just so you know, this is how that works. All right? And that's it. We're actually done with that screen. And there it is. So now it's displaying that screen because we're at that default route. And if we look in the browser, you would actually see that this is, let's see if I can show you. It's so tiny, I should probably learn how to use the magnifier. Right there is a router, is our router view component, and inside of that is the HTML that we declared for that screen. So you can see that router view is actually rendering that in place when the route matches. So next thing we want to do is get our contact list up here. So I want to create a component that's completely self-contained that has our contact list. And we want to drop it in on the left side. See how we're doing on time here. We're doing pretty well. First I want to show you the code that I want to write. And then I want to show you how we're going to actually build the contact list. So to do that, I want to go back to my app HTML file. And what I really want is on that left side of the screen, I want to have something called a contact list, like this. Thank you very much. Yep. Live coding. So this is the code I want to write. And when I render it, when I go and look at it in the browser, I want to see that contact list displaying on the left-hand side. So how do I build this? Well, I already told you, so hopefully you remember and hopefully you trust me. We're going to create contact-list.js. And then we're going to also create contact-list.html. Okay? I want to first show you the JavaScript for the contact list. Again, it's a pretty straightforward class. We're importing that web API because we want to call it to get back our list of contacts. We're using the same dependency injection technique where we're saying, please give me an instance of that API in the constructor. Also in the constructor, we're setting up an array of contacts. Thank you very much, whoever just did that. And then there's this method called created. And this is the callback that the framework will give you. Once it's actually created your, instantiated your JavaScript class and instantiated the template, it's going to call this created callback so you can do some work. And in this, I'm actually going to call the API to get my contact lists. That's going to return a promise. And when that resolves, I'm just going to store the contacts on the class itself. I also have this other API down here for selecting a contact, and it's going to take a contact in, and it's going to store the selected ID of that contact on the class as well, and then return true, so that the browser can continue to process the event. So how does this look? How does this work together? Well, here's the HTML. And now you're going to see a little bit more of the data binding and infrastructure that we provide here. So first, just some basic classes that you would expect. And then we have this li tag. And then if you look on the li tag, you see that we have repeat.for contact of contacts. So again, in aligning with the future web and ECMAScript 6, we have borrowed the syntax for the for of construct in ECMAScript 6. If you're not familiar with that, there is finally a way in the browser to iterate over arrays without using a for loop. You can, it's like a for each from other platforms, so it's called for of. And in fact, it can iterate anything that implements the iterable interface in JavaScript. So you can even create your own classes that can now be used with the for of loop. So we like that syntax. That's part of the ECMAScript 6 specification. So we basically have reinterpreted it for HTML. So we're saying repeat for contact of contacts. And what that's going to do is it's going to render out this li for everything, each element in the array. And then you can see inside of there on line 5 that we've got string interpolation again for the href of the link, right? So we're going to basically generate that link based off of the context ID property. And then you can see inside of the h4 and inside of the p tag, we're also doing that same string interpolation technique to bring in the first name, the last name, and the email. And that's building out our little item template. You can also see some things happening over in the class tag on the li, where we're actually dynamically binding what classes are on that li based off of whether the ID equals the currently selected ID. You can't quite see that, so I'll just scroll that over real quick. So we're adding the active class only if the item's ID is equal to the selected item. So dynamically adding classes. All right. So that's a little bit more of our binding syntax there with repeaters and class binding and a little bit more string interpolation. But again, look at our JavaScript. It's just a clean, simple, plain class. Now, if we were to run this, and we will, come over here, nothing's going to happen. I showed you the code I wanted to write, but I left out one important detail because it's not quite what we're going to write. What we are going to write, though, is we're going to import this custom element. And again, borrowing from ECMAScript 6, anytime you want to bring in components into a view, you import them into that view. Now, there is a way to specify a set of global components, so you don't have to do this in a tedious fashion for every single view if you've got things you use everywhere. But for the most part, we want to componentize our HTML the same way that we do our JavaScript. So if you want to use this contact list, you use an import in your template, and Aurelia will go load that up, and it'll make it visible inside of that view. And there it is. So there's our list. And that's it. That's all there is to creating and importing a custom element. And you can see, again, it's that simple pattern. Simple class, simple HTML with binding expressions, all based on ECMAScript 6 syntax. If I select one, then you'll see that nothing happens. And in fact, I get an error. I should be getting an error down there. And that's because it's trying now to navigate to the details screen, which we haven't built yet. So let's go ahead and build out our details screen. And then we'll be able to navigate between them. So moving back over to my code editor. That's right, you guessed it. Same pattern. So we're going to create contact details.js. Is that what we named it? Let me just double check. We're going to look, just so you can be reminded of the relationship. This is based off of what we set up in our router to match on the patterns. So that contact with an ID in the URL, we want to map to a contact detail module. So that's the name that we want, contact detail. So let's go ahead and create contact detail.js. And let's create contact detail.html. I'll go ahead and start with the HTML on this one so we can just kind of look at it. There's a lot of it, but it's not complicated, okay? Most of it's just bootstrap classes I put in there to make the thing look halfway decent. The interesting parts are on these inputs. And you'll notice out here, whereas before we had repeat.for, here we've now got something value.bind. Now Aurelia leverages these things called binding commands. So anytime you see a dot, you know that the thing on the right-hand side of the dot is a custom command for the binding system. So repeat.for or value.bind. This tells the binding system how to synchronize the data from your class into the HTML. And value.bind is a simple data binding. Usually it's one way, so it brings data from your model into your view, only in that direction. The one exception to that is with form controls. So we figure if you're binding to an input text, or to a text area, or to a select, or something like this, you probably actually want to know what value the user types into that text box. So in that case, we make the binding two-directional. So we'll flow it from the model into the view, and when they change it in the view, we'll flow it back into the model. You can actually control this by saying one way. So you can customize this always. That's just the default. You can say one way, two way, or you can even say one time, in which case it won't observe any changes in the model. It will just pull the data out at render time and put it in there, and then it won't update it again. So you can use that for performance optimization. So we've got, what did I do there? Yep. So we've got basically a form here with a bunch of inputs bound to things called contact phone number, contact email, contact last name. So let's look at the JavaScript file for this. And this one's a little bit more complicated because it does some interesting things. But again, it's just a class, importing things, having dependency injection, give us our app. Actually, that doesn't need to be there, and our API. Let me simplify this a little bit, because we do not need this at all, actually. I can tell I didn't quite clean up this code. So that's what we need. So all we need is our API. Then you can see this activate callback. So this is something new that we haven't seen before. Whenever a screen is routed to, and we're about to display that new screen, the router tells that screen, hey, you're about to activate. And it gives it information. In that first parameter, you can see params. So the router has pre-parsed the parameter data out of the URL. And based off of what we named it in our route config, you're going to have a property there. So you can see on params, there's a property called ID. And that matches our route definition here. So we're going to give you the params so that you can load data, for example, which is what this is doing. So it's taking our API, it's getting the detail information for the contact using that ID. That returns a promise. It's then storing that contact as a property on the class. And that's how we're then able to data bind it over here with contact last name, contact email, etc. Very simple, very straightforward mapping between the two. The router also gives you some other things as well. So for example, if you've got query string, it will pre-parse the query string and hand you that as a nice object. And also gives you the config object, which is your original router configuration. So if you want to store custom properties on that, you can get access to those here. The nice thing it does, though, it gives you something called a nav model, which is a model we build up, which we synchronize with the document's title and with any menus that you create. So you can see on line 14, when we're setting the title to the contact's first name, that's actually going to update the browser title for us automatically during the render. So we don't have to worry about any of the details of how that's happening. We just set that property up and we're good to go. Now I've also added some other functionality here, the ability to save, which just calls out to our API and saves there. Notice I'm storing the original JSON when we first load it and then updating it when we saved. This is because I want to introduce you to a new concept in the router, which is the ability to cancel navigation. So imagine you're editing a contact and you didn't save it and then you navigate away. Well, you might want to prevent the user from doing that and losing their data. So you can implement a callback called can deactivate, and before the navigation happens, it will ask your class, can I actually deactivate you? So what I'm doing here is I'm comparing the original JSON from when the data was first loaded to a stringified or JSONified version of the current data. And if they're not the same, I'm popping up a confirm dialog box and letting the user decide whether they want to leave or not. And then I'm returning true or false back to the navigation system. And that's pretty much it. We got another property called canSave, which will enable whether the button is clickable based off of whether we put minimal data in there. And that's basically how this screen is built. So again, it's a pretty short, small class. There's a lot of functionality in here, though. Let's take a look at that. And there it is. Now as I load this up, it's loading based on the ID, the different contacts, and displaying that form. And you may be wondering why it's taking so long. I just want to remind you this is not because the framework is slow. It's because of inside of that web API, I'm simulating a 300 millisecond network API, right? So if it's a network latency. So if it looks like it's taking a second, it's because I'm trying to simulate the real world here in terms of hitting the internet to get data. But there it is. So as we click on that, that updates the URL. That then triggers the router. It matches that route. When the route is matched, it knows it needs to go load your contact detail class and view, bind them together, and then inject them into that location in the screen. Notice that if I delete the first name here, the button just became disabled. I think the screen is cutting it off, actually. The save button, though, is no longer clickable. But if I type it back in or start to type it back in, it then enables. So that's because we've bound in HTML the button's disabled property. So disable bind to if I not can save, right, then it's disabled. And you can see that is this property right here, which is doing some internal logic. All right, and let's just test out one other thing. If I have started to edit things and then I try and navigate somewhere else, and the values are different, there's that deactivation piece coming into play right there. It's stopping me from navigating, and I can cancel or I can continue. So I'll just say continue. All right, I want to do one final piece before we end with our app building. Let's see how we're doing on time. Looks like we're still doing pretty well. I want to implement that loader so that as we're going from screen to screen, you see that little loading animation and the little spinner and all that. Before we do that, I want to show you again how I would like to write that. I'm going to come over to my app HTML, and I'm just going to drop this in here. I think what I would like is to just have a loading indicator like this. So I want to have a custom element I can just drop in there that's a reusable loading indicator. I actually will be able to use it on any app that I build. So let's make that. How do we make that? Well, there's actually two pieces to this. First, I'm actually going to use a third-party library because I actually don't want to build all of that myself. I just want to give it a nice API in my app and make it reusable and make it data bindable. So I'll show you how we'll do that in a minute. So I'm going to bring in a third-party library. I've actually already brought it in because I wasn't sure if I could trust the network, but I want to show you how I would do that. And this is using JSPM. So if you remember, we would type JSPM. This is our package manager. I happen to know that there's a library out there called in progress. So I would say JSPM install in progress. And then I would hit enter. And what it would do is it would go out to the registry and it would find it and it would download it. It would detect its module type. It would set up all the configuration and put it in a versioned folder in my project. And then at that point in time, we can actually import it using ECMAScript 6 module syntax, just like any other module. So again, I'm not going to do that because I've already done that ahead of time. I'm going to start our server back up again. What we are going to do is we're going to create this loading indicator now that we've got that third-party dependency in. So how do we do this? Well, we're going to create loading indicator.js. I'm going to do something a little bit different with this. I'm actually not going to create an HTML file. And the reason is because this is actually a third-party library that does all of its rendering in JavaScript code. So we don't actually need an HTML template. We're not going to do anything custom there. We're going to let this third-party library do all that for us. So I'm going to show you a new concept in Aurelia called metadata, which lets us control how these classes are utilized by the templating engine. And so this is called loading indicator. Don't you wish you could just type the name of your file and your code would write itself? So look at line 1. Once we've JSPM installed in progress, then we can actually import it with the module system. That's it. That's kind of the beauty. This is the world what we're looking at with JSPM and ECMAScript 6. This is the same way that you would do if you were working in Java and you brought some jar in and then you were importing that, or if you're working in .NET. I have a .NET background, so I might install a NuGet package and then I might use a using statement in C# to bring stuff from those assemblies in or whatnot. Pretty much every very mature platform has a way of bringing in packages and then importing some types or objects or functions or something into your class to use. So that's what we've just done here. We said, install this package, I want to use this thing, and now I'm going to import it into my code and use it. So one line install and a one line import. So now we've got our in progress component coming from a third-party library. Line 2, I'm bringing something in from Aurelia's framework called behavior. And this is how we're going to control the behavior of our loading indicator, how it plugs into the HTML templating engine. And to do that, we create a static method on the class called metadata. And it's going to return this behavior object that we're chaining a bunch of method calls off to configure. So we're going to create a custom element called loading indicator. Now, last time we created that contact list, you notice I didn't actually have to do this. That's because of the naming convention that Aurelia uses. So we could actually remove line 7, and it would pull loading-indicator by convention from the class name of loading indicator. It would lowercase it and hyphenate it so it's usable in HTML. But I'm being explicit here and showing you how that works. It worked automatically in the other case. So we're saying, hey, this class has a particular kind of behavior. It's a custom element with this name. It also has a property on it called loading. When you declare a property like this, it tells the binding engine that, hey, there's a custom attribute on my custom HTML element that you're going to be able to data bind to. All right? And then it's saying there's no view, right? Because we don't want it to go find that HTML file, because this is actually really being entirely handled by the in progress component. We're just wrapping it up in a nice, reusable HTML element. There's also another convention whenever you have these bindable properties, that you can create a method on your class with this naming, with the name of the property and the word changed. So loading changed. And every time that property gets changed through the HTML or through the data binding system, this callback will be executed. So you can see every time loading changes, based on its value, we're either going to start or stop the progress indicator. And that's it. So let's use this in our code. Let me save it real quick. Come back over to app.html. The first thing that we remember to actually get this to work is we're going to need to import that, right? So let's go import from if I can type loading indicator. So now we've imported it. If we run it, nothing's going to happen. I'm executing the wrong browser. Nothing's really going to happen here if we refresh and we start navigating around. And why is that? Well, it's quite simple. We gave this loading indicator this custom property called loading, and only when that gets set to true are we starting, or sets to false are we stopping the loading indicator. So nothing is causing that to be altered. So how are we going to do that? Well, we're actually going to set this loading property in our HTML the same way we've been setting all the other properties. So on our custom element, we've got this property called loading. We're actually going to bind it. And what are we going to bind it to? Well, let's look at app. We've got our router and we've got our API. And the router actually has something called isNavigating, which is true whenever the router is navigating from screen to screen. So we're going to say that we want to display the router, the loading indicator whenever the router is navigating. I also built our API so that this API has a similar property on it called isRequesting. So anytime we're making a web request, that API is going to set that isRequesting to true. So we can also do this. And now what's going to happen is that loading indicator, that loading value is going to change and update based off of whenever the router is navigating or the API is requesting. And when that value changes, our callback gets called. And we either enable or disable that in progress component. Okay? So let's go ahead and see it. Now we've broken something else though. Let us see what we do. Oh, I'm sorry. Contact details.js. That is certainly unexpected. Let me try and reload here real quick. Contact detail. And see if we can fix the issue. Host dist. That's very unexpected. It can't. Did I have a bug? Or was it? Sorry. Oh, thank you. How do I do that? Just a slip of the hand, I guess. Can happen. Is there another line 6? I'm not seeing it. Oh, yes. Thank you. Perhaps this is a point in time to mention the language TypeScript, actually. So if you don't like running into these kind of errors and you want strong typing, TypeScript is actually about to, is moving towards their 1.5 release, which has pretty much almost entire compatibility with ECMAScript 6. And there's a lot of compile time checking on syntax and types and all this kind of stuff. So if you're coming from a C# or a Java background or something like that, and you're used to that kind of a tooling, TypeScript 1.5 is going to work amazingly with Aurelia, and you're going to get those kind of features as well. So you won't make the error that I just made. Hopefully that's all of our errors. Might need to restart the server. Yeah, I broke it. Thank you. Or I stopped it on purpose. So good. Okay, there we go. And now you can see the loading indicator is displaying as we're loading. If I come over here and I click save, it's also going to display as I'm saving, because we tied in that value of the loading property to when the API was requesting or when the app was navigating. All right, so that is our sample app. And what I hope you gain from this is, you're going to walk away and you're probably going to forget all the details, but I hope what you gained is that there's this very, very simple pattern for creating things. It's hard, if you can think of a simpler way to do it, please do let me know. But we think creating a simple ECMAScript 6 class with not too much around it, not too many special fancy API calls, and then having an HTML template with these simple, readable, binding expressions based on ECMAScript 6 itself, let you have a very simple and straightforward way for creating things. And use this, like I said, use this same pattern over and over again for everything you create. It doesn't matter if it's a custom element, or if it's a full screen, or if that screen is broken down into sub-pieces inside of it. Use the same pattern. So you don't have to worry about thinking too hard about the framework. You can focus on the app that you're building, the unique characteristics of your app, or the business modeling that you're doing. So let us hop over to our slides and continue where we left off there. So, what's the status of Aurelia and what are we working on next? Well, first we're in what we call public preview. It's basically like an alpha. So we're not production ready yet, but we're working very fast towards a stable beta, which will hopefully happen in the next 2 to 3 months. At that point, we'll basically say we're production ready. We're just not going to quite call it the official 1.0 release yet because we want to let that kind of bake for a little bit and make sure we work out any remaining bugs or performance issues. Okay, so we're in a preview stage right now. It is pretty much fully featured. I only showed you a fragment of what you can do, but there's an animation system in there. The routers, you can have other classes that have child routers and you can nest routing. We have something called another custom element called Compose, which lets you dynamically construct UI based off of data on the fly. You use the same pattern to create things though. But there's lots of other interesting features that go into building very rich interactive experiences with JavaScript. And we pretty much have all the features in the box now. There might be 1 or 2 little things still remaining, but pretty much everything is there. We have preliminary documentation. We've got plans for much richer documentation, but you can go on Aurelia.io and you can read a Getting Started guide, which will take you through building a simple application. The app that we built today is all up on GitHub also. If you look in the Aurelia organization, look for the repository called app-contacts. That's the whole app plus a few extra things we didn't get to today. And we're actually going to be building that all out. And then we're going to put a video series up on that as well that will take you end to end, even more detail than what we did today. There's a video on the website too to get you started. So there's a lot of good content there. It's not as much as we want, but if you want to play around with this or you want to explore whether it makes sense for the next app you're building, there's enough there. There are real apps in development already. So like I said, we only announced this about 6 or 7 weeks ago. I was working internally, privately with some companies who were early adopters before that to build some pretty serious applications. And the community is already also building apps. We've got people building for tablet and phone already, for desktop. We have people working in the energy industry. We have people building consumer-based apps already. Bear in mind, like I said, we're not production ready yet, so if you need to be there next week, you need to make another choice, okay? So you're going to have to kind of play your timing of your project based on that. And like I said, there's been a really rapid adoption so far. People are really liking what they're seeing coming from other frameworks. I think the simplicity resonates with people, the cleanness of the code that you get to write, the embracing of ECMAScript 6. So the community is actually growing and very active right now. What are the next steps for Aurelia? What are we doing next? Well, we're working on a command line tool so that we can do some more automation for you. So if you want to create a new project, it's easier to create a new project. You can download the Aurelia CLI and say Aurelia create foo, and it will just build it all up for you. We'll have some other scaffolding tools in there for you to do that will help with testing. And the big piece in that is going to be bundling. So you saw me creating all these individual files, HTML and JavaScript. Well, you don't want to deploy like that because then you end up with hundreds of HTTP requests, and that's bad for performance, particularly the initial load time of the app, which is when you're likely to lose customers if they're coming from the web. So this is kind of our biggest reason for saying we're not production ready yet, is because we haven't finished our bundling tool. And what that will allow you to do is basically say, here's my app, please bundle it all into a single file or into a couple of small files and things like that. We want this to be very robust because we know that people are also trying to build very large applications that can't be bundled into a single bundle, but need to be bundled into multiple bundles and dynamically download based off of feature or what the user is doing and so on and so forth. So we're working and we're actually contributing back to the JSPM project to actually improve bundling across the entire JavaScript community through that library. And so we've got a pull request waiting on that. Once that's taken in, we'll then have the low-level capabilities to build our custom bundling on top of that. And that will also be, we'll make that really easy through our command line tooling. So that's a big next thing that we're working on. So what browsers does this support? Well, currently it supports only the most modern browsers. This means Internet Explorer 11, the latest Chrome, Firefox, and Safari. However, we discovered that we can do just a little itty bit of work and we can actually get the full fidelity experience running back even to IE9. We can't do IE8. There's a significant difference between IE8 and IE9, but we have identified and have our demos up and running with IE9, and we're in the process right now of actually getting IE9 working. So for some of you that can't do the absolute latest browsers for what you're building, we're going to support back to IE9. really excited about this because this is something that the other next generation frameworks are not doing. We want to stabilize the API before we call this a beta. We're about to go through a few breaking changes in the next few weeks in order to actually try and simplify things a little bit more, in order to prepare for bundling and a few other things. So if you want to get started today, you just can kind of keep an eye on that and track what those things are. But that's another reason we're not in beta yet. We kind of have to break a couple of little things in order to fix them. And we want to get that out of the way as soon as possible so people don't have to worry about that for a while. We also want to do a lot of performance optimization. It's not slow by any means, particularly on desktop, but when it comes to mobile, we really need to tweak things a whole lot in order to get it as smooth as possible on mobile. And so we've got a whole list of things that we know we can do to make it even faster than it is. And we would like to do that work before we call it a 1.0 or before we call it a beta. So again, it's not slow, but we can always make things much faster, and we've got a bunch of things we can do in that area. We want to have rich interactive documentation. We're actually working on this right now. In fact, we're building the docs with Aurelia itself. We're creating a custom markup language for interactive documentations by using the same behavior patterns that I showed you. So we're actually creating custom HTML elements and different things like that that surround the ideas of creating interactive documentation for our platform. And then we're going to write our documentation in that. And you as a community will also be able to contribute that way as well. And this will let us handle localization. This will let us handle loading samples inline that you can interact with. And this will also let us write a lot of stuff in Markdown and do a bunch of other interesting things that make just documenting easier. So we're building that out. And this will actually be another app that you can look and see how it's built with too. So that'll be really fun. The whole source for our docs app will be up on there. And then of course our docs will be there for you to read and contribute to if you want. So all this is sort of marching towards the beta. And we hope all this is happening right now. Some of it's farther along than others, but all of it's in progress. And so we hope in 2 to 3 months to be in the beta and to be done with any kind of breaking changes and to have all the pieces that are needed to go to production ready. And then we can just kind of sit there for a little bit and work out any bugs that the community finds or that we find in our projects. And at that time, also hope to have a bunch of rich plugins. So I didn't show that to you today, but we've got basic animation support in the library, but it's abstracted, so you can actually plug in whatever animation library you want. So as of today, we've got Animate CSS support. It actually just got pushed to our repo this morning. So that's completely CSS-based animation. You can drop that in for animation. But we're also going to do things like work with GreenSlock and Velocity and some of the high-performance JavaScript-based animation libraries that are out there. The idea is you choose how you want to handle animation. You then install a plugin. We have a plugin API. I didn't get to show you that, but it's there. You install a plugin, and then you just kind of proceed along your way, and that handles the animation for you. We'll have a validation plugin that we're coming out for doing forms-based validation. We're also working with third-party vendors, various data libraries, for example, like Breeze.js, to have plugins, so you can just drop that in and have a really nice experience. And again, how you would do that, JSPM install my plugin, and then in your configuration for the app, you would basically say, all right, here's a plugin I want. Make sure this is loaded before you do anything with render my screens or anything like that. All right, that is the end. Thank you. We do have about 5 or 6 minutes, I think. If anyone has any questions, I'll try and address them. Any questions? All right. Well, thank you for coming, and I'll be around. Oh.
Well, I guess how did you convince the company to go towards Aurelia? What is it?
Right. So how would I convince a company to choose Aurelia instead of some other framework by mega company X, like maybe Angular 2? There's actually a bunch of reasons, and I don't want to. I have to be careful about how I talk about that because there's some very technical reasons, some of which have been skirted around by other companies. But I will say, if you're following very carefully, you'll notice that Angular 2.0 does not support two-way data binding. And this is a big departure from Angular 1. And most people I've talked about in that community that have used Angular a lot of people picked it because of that feature. So it only has one directional data binding, and it has other means of kind of trying to get data back, which in my opinion are not either elegant, and they're also quite intrusive into your code. So if you want that feature for productivity and simplicity and cleanness of code, then you pick Aurelia. So that's an example of the feature. There are other issues like that. There's a kind of a pile of them. I'll probably be blogging about this now that the alpha of Angular is released, so that people get a clear idea of like what are the technical differences between the approaches. So that's one reason. Another reason, as I mentioned, commercial support. Okay, so if you work for a medium-sized company or if you work for the enterprise, oftentimes there are also requirements to be able to have support for things like this. So Google, to my knowledge, can't and is not going to provide anything like that. Angular is not an official product of Google in the same way that like Gmail is, for example. So they don't provide anything like that, and we will provide that for Aurelia. There's a bunch of other things I can't really share yet about what we're doing, but in short, we have a very serious business model behind this. Aurelia is, we consider one of our products. It is an open source MIT licensed product, but we want the community to kind of work with us around that, and that will always be open, MIT licensed, very permissible. But we're going to also have a bunch of offerings kind of around that to create an entire ecosystem that is much more like what you would expect if you were coming to a native platform. So we are actually in the process of building a business right now and basically getting funding to build this out the same way you would expect from like I said, from a native platform. But the key characteristic of that is, of course, that the core and this baseline, which is extremely capable, is entirely open source and driven by the community. And we want to set up our company so that the company lives and dies based on the success of this framework and everything around it. And we want to build our own tools and our own products with the framework. When you have a large company that builds these kind of things, it doesn't really matter whether the product fails. And they can make changes that that they can handle internally because they have so much money, and they don't really feel the pain that the average company feels when these things happen. So we want to actually have a company building this thing that feels the same pain that its developers would feel from using it, or from changing it, or from dealing with cross-browser issues and whatnot on a larger scale. So this is a really important issue as well. Commercial support and having a company that's backing it where its entire product line is based on the success of the thing and the correctness and the functionality of it. The technical issues, there's actually a lot of them. I just named one. I'll write a blog post about that. When you see it, it'll make sense to you. I don't have time to go through all of them now. If you compare the code side by side, you can see there's a huge difference in maintainability of the code. Aurelia is just plain JavaScript. Other frameworks like Angular force you to kind of put a lot of other stuff in there. And even if you look at Angular 2, they use annotations. There are situations where you get so much annotations, your class is like this, your code is like this, and then the annotations for the framework are like this. All right, so you can't even see your own code. So these kind of issues are costly for maintenance reasons. And if you ever need to switch a framework down the road, let's say that Aurelia a disaster happens and it's just gone and you need to change. Well, it's not as big a deal, right? Because we kind of support this Pojo or Poco type model where your classes are just JavaScript. So you don't have to go extracting a framework out of your code in order to take the code that you've written and reuse it. We're also a lot more standards compliant than some of these other libraries. Angular's binding syntax, for example, does not work with SVG. Ours does. I didn't show binding to SVG, but you can bind to SVG. There's a lot of technical details like that make a big difference when you're looking at where you want to kind of build on. I could go on for a long time, but we really are probably out of time on that. We can talk more. Any other questions? All right. Thank you. I hope you'll try it out and send us feedback. We're really excited. So thank you for your time.